Morning, Junior 6. Let's start to complete our lesson, which is called Mass and Weight. Let's recap the definition of the weight. It's the force by which the body is attracted to the earth. It's the force by which the body is attracted to the earth, or it's the gravitational force acting on the body's masses. And the properties of weight: the effect of the weight always directed to the center of the earth, and on the earth all the objects have weight, but in the space all the objects are in a state of weightlessness, so the weight in a space equals 0 because there is no gravitational force. So the weight in the space equals 0. And the weight is not a fixed value because it differs from one place to another. And the measuring unit of the weight is called Newton, and 1 Newton equals 100 grams. And the measuring device of the weight is called spring scales. This is the spring scales. It consists of 3 parts: top hook to hold the scale, and bottom hook to hang the object up the scale, and a spring with a pointer, So the measuring device is spring scale, and the measuring unit is Newton. So the weight in space equals 0. Why? Because there is no gravitational force. And the weight of an object is not a fixed value because it differs from one place to another, because the gravitational force changes from place to another. Now we are talking about the factors affecting the weight of an object. The weight of any object are affected by 3 factors. The weight of any object is affected by 3 objects, which are: number 1, the object's mass, or the mass of the object. Number 2, the planet where the object exists, or the place where the object exists. And number 3, the distance between the object and the center of the earth, or the center of the planet. So there are 3 factors affecting the weight. What are they? The mass of the object, the planet, and the distance between the object and the center of the planet. Let's start with number 1, the object's mass. When the object's mass increase, its weight will increase. So you can calculate the weight of an object on the Earth's surface according to the following rule. The weight of the object on the Earth's surface by Newton equal its mass times 10, but the mass by unit in kilogram. So you can calculate the weight of an object on the Earth's surface. The weight of the object on the Earth's surface equal mass times 10. And the gravity, or the Earth's gravity, equal 10. By the gravity equal 10. So you can calculate this triangle from this rule weight equal mass times 10. Weight equal mass times 10. This triangle, it will solve any problem. So, problem number 1. The mass of a person is equal to 70 kilogram. Calculate its mass on the Earth's surface. The mass of the person equals 70 kilogram, so calculate its weight on the Earth's surface. The weight on the Earth's surface from the triangle equal mass in kilogram times 10. So 70 times 10 equal 700 Newton, because the Newton is the unit of the weight. Problem number 2. Calculate the weight of an object on the Earth's surface. If you know that its mass is equal to 500 gram. Concentrate, Junior 6. The mass in kilogram, not in gram. So you have to change gram to kilogram. So the mass equal 500 divided 1000. So it equal half kilogram. So from the triangle, the weight of the object on the Earth equal mass in kilogram times 10. So it equal half times 10 equal 5 Newton. Problem number 3. If the weight of an object on the Earth's surface is equal to 300 Newton. Here, if the weight equal 300 Newton, calculate the mass of this object. Now he need the mass, so hide the mass. From the triangle, hide the mass. So the mass equal the weight of the Earth's surface divided 10. So it equal 300 divided 10. So it equal 30 kilogram. Any problem? Super. The second one, or the second factor that affect the weight, is the planet. The planet where the object exists. The weight of any object differ according to the planet or the moon. The weight of any object differs according to the planet or the moon where the object exists. Because when the mass of the planet increases, its gravitational force will increase. So the weight of the object will increase. So by increasing the mass, the gravitational force of the planet will increase, so the weight will increase. Okay? So what is the factor number 1? The object mass. By increasing the mass of the object, the weight will increase. And by increasing the mass of the planet, its gravitational force will increase. So the weight of the object will increase. So, on measuring the weight of an object on the Earth's surface, then measure the weight of the same object on the moon's surface, we notice that its weight changes from the moon and the earth. The mass, its fixed value, doesn't change by changing the place. The mass, it's a fixed value. So the mass of these people is 36 kilogram on the earth and on the moon, because the mass, it's a fixed value, doesn't change by changing the place. But the weight change from the earth to the moon. Why? Why the weight change from planet to another? Because the earth has greater mass than the moon. So the weight of the object on the moon's surface equal 1/6 or 1/6 of its weight on the earth's surface. The weight on the moon equal 1/6 the weight on the earth. The weight on the moon equal 1/6 the weight of the earth. Why? Because the earth has greater mass than the moon. So the earth has greater gravitational force than the moon. So the weight on the earth is greater than the weight on the moon. Because by increasing the mass of the planet, its gravitational force, it will attract the object strongly. So the weight of the object will increase, and the weight of the object on the moon is equal to 1/6 the weight on the earth. So you can calculate the weight of an object on the moon according to the rule. The weight on the moon's surface in Newton equal the weight on the earth times 1/6 times 1/6. The weight on the moon equal the weight on the earth times 1/6. So you can calculate the triangle number 2 from this rule, that the weight on the earth equal weight on moon times 6. If you need the weight on the moon, so hide the weight on moon. So the weight on moon equal weight on earth divided 1/6. If you need the weight on earth, so hide the weight on earth. So the weight on earth equal weight on moon times 1/6. So you have two triangles to solve any problem. Triangle number 1, weight on earth equal mass times 10. And the triangle number 2, the weight on earth equal weight on moon times 6. Let's solve these problems. Number 1. If the mass of an object on the Earth's surface equals 60 kilogram, calculate its mass on the moon's surface, and calculate the object weight on the Earth's surface, and calculate its weight on the moon's surface. What is the mass of the moon? The mass on the moon's surface is equal 60 kilogram. Why? Because the mass is a fixed value. It doesn't change by changing the place. So the mass is equal. It's a fixed value. doesn't change from Earth to the Moon, doesn't change from place to another. Number 2, the weight on the Earth. The weight on the Earth. From triangle number 1, the weight on Earth equal mass times 10. Mass times 10. So mass equal 60 times 10, so it equal 600 Newton. So the weight on Earth equal 600 Newton. Number 3, the object's weight. The object's weight on the Moon. You need the weight on the Moon's surface. The weight on Moon from triangle number 2, the weight on Moon equal weight on Earth divided 6. So the weight on Earth equal 600 divided 6, so it equal 100 Newton. Problem number 2. A body whose weight is 20 Newton on the Moon's surface. Body, the weight on Moon equal 20 Newton. Calculate its weight on the Earth and its mass on the Earth. Number 1. The weight on Earth equal what? From triangle number 2, the weight on Earth equal weight on Moon times 6. Weight on Moon times 6. So 20 times 6. So the weight on Earth equal 120 Newton. And from triangle number 1, the mass of an object, he need the mass, so hide the mass. So what is the rule? The rule is the weight on Earth divided 10. So the mass of the object equal 120 divided 10, so it equal 12 kilogram. The last factor that affects the weight is the distance between the object and the center of the Earth. The distance between the object and the center of the Earth or of the planet. The weight of any body decreases when the distance between the body and the center of the planet increases. When the distance between the object and the center of the Earth increases, so the gravitational force of the planet will decrease, so the weight will decrease. If the distance between the object and the center of the Earth increases, so it can't attract the object to the center of the Earth. So its gravitational force will decrease, so the weight will decrease. So by increasing the distance between the object and the center of the Earth, the gravitational force will decrease and the weight will decrease. So the weight of a person in a flying balloon is smaller than that on the Earth's surface. The weight of a person in a flying balloon is smaller than that on the Earth's surface, because as we go away from the center of the Earth, or as the distance between you and the center of the Earth increases, the gravitational force of the Earth will decrease, so the weight will decrease. So there are 3 factors affecting the weight. Number 1, the mass of the object. By increasing the mass, the weight will increase. And number 2, the planet where the object exists. And by increasing the mass of the planet, its gravitational force will increase, so the weight will increase. And the last one is the distance between the object and the center of the Earth. By increasing the distance between the object and the center of the Earth, its gravitational force will decrease. Its gravitational force will decrease, so the weight will decrease. So the weight of a person in a flying balloon is smaller than that on the Earth's surface. So the factors affecting the weight again. Number 1, object's mass. And you can calculate from this triangle number 1 that the weight in Newton equal mass in kilogram times 10. So the weight or the factors affecting the weight, there are 3 factors. Number 1, mass. Number 2, the object's place, and the distance between the object and the center of the planet. Now we can make the comparison between mass and weight. In the definition and the units and measuring tools, directions and effects of the changing place. What is the definition of the mass? Mass is the amount of matter in an object, while the weight is the force by which the body is attracted to the earth. Mass is measured in gram and kilogram, but weight is measured in Newton. The measuring tools of mass is balance scale, sensitive scale, one-arm digital scale, and one-arm scale with a pointer. But the weight is measured by the spring scale. The mass has no direction. The mass has no direction, but the weight always directed to the center of the earth. Always directed to the center of the earth. And the mass is a constant value. It's a fixed value. It doesn't change by changing the place, but the weight is variable. It's changed by changing the place. They change by changing the place. And there are 3 factors affecting the weight, which are the object mass, the place or the planet where the object exists, and the distance between the object and the weight.